Hi everyone, Mr. Vidich here. Okay, we're going to do lesson 2.3 today, integral exponents. As we all remember from unit 1, integral is another way of saying integer. So what that means when we say integral exponents, our exponents can be negative numbers as well. So -3, -2, -1, all the way 0, 1, 2, 3, and so on. So today we're going to look at negative exponents for the first time. So let's just go through this example here. So 10 to the 3 is 1,000, 10 squared is 100, 10 to the 1 is 10, 10 to the 0 is 1. So we've covered all those in the first couple lessons. So let's look at let's look at negative 1 here. So if we follow this pattern here, okay, 3 zeros, 2 zeros, 1 0, no zeros. Okay, what would that look like as if it's 10 to the -1? So we have 1 over 10, or if we follow this pattern, it would be 0.1. Okay, here's the decimal. 10 to the 3, decimals over here. 10 to the 2, decimal shifted 1 over here. 10 to the 1, the decimal shifted twice. 10 to the 0, decimal shifted 3 times. And then here, the decimal shifted 4 times, 10 to the -1. 10 to the -2 would be 1 over 10, or 1 over 100, which is 0.01. Okay, well, if we keep going down this pattern, okay, we know the answer for this one is going to be 0.001. Okay, and that's because when we write this, it's going to be 10 to the 1 over 10 to the 3. So let's look at the same example, but for 3. So 3 to the power of 3 is 27. 3 squared is 9. 3 to the 1 is 3. 3 to the 0 is 1. Anything to the 0 is 1, which would make 3 to the -1 1 over 3. Okay, 3 to the -2 would be 1 over 3 squared, and 1 over 3 cubed. Okay, so there we go for those, and you can fill in the answers there. So that's the pattern when we have negative exponents. So a to the 0 is 1, a to the -1 would be 1 over a to the -2 would be 1 over a squared, 1 over a cubed for a to the -3. Write the following with a positive exponent. So let's change this from a negative exponent to a positive exponent. But again, 1 over 10 to the +7, 1 over 3 to the 5, and 1 over a to the n. Okay, so again, that's basically the main point of this lesson today, is that anytime you have a negative exponent, you're going to do the reciprocal of that of your number, and to turn the exponent into a positive exponent. Okay, we'll do a few more examples down here. Okay, so consider the expression 5 to the power of 4 divided by 5 to the power of 7. Evaluate the expression as an exact value using a calculator. Okay, let me get my calculator out here. All right, so 5 to the power of 4. Again, to get large exponents, we use this little hat button here. 5 hat 4. Enter, divided by 5 hat 7, and we're going to get 0.08. If I want to turn that into a fraction, I get 1 over 125. So 1 over 125. Now complete the following. Okay, so to evaluate the expression, so let's look at this in full detail here. So I have 5 to the power of 4 divided by 5 to the power of 7. So I have 5 times 5 times 5 times 5 times 5 times 5 times 5. Okay, so 1, 2, 3, 4, 5, 6, 7. So if I have that as my denominator, okay, I can just start crossing out some 5s here, and I'm left with 5. Well, all the 5s are gone on the top, so there's a 1 there. We write a 1, and then on the bottom 5 to the 3. And 5 to the 3 is 1 over 125. Okay, and there's that answer up there. So again, let's use it, using another method here. We can use what we learned last class, 4 minus 7, and we get 5 to the negative 3. And again, 5 to the negative 3, as soon as you see that negative exponent, you want to make it positive. So let's flip it around. Okay, do the reciprocal. This is, by the way, 5 over 1. So when I say reciprocal, 5 over 1, the reciprocal is just, 1 over 5. Okay, so you just flip-flop that fraction around. That's how you make the exponent positive. And then 1 over 125 is the full answer there. So it says the resultant A to C are examples of a general rule when the base is raised to a negative exponent. So A to the negative P is A to the 1 over A to the positive P. Okay? Okay, let's keep rolling on here. So write the following with positive exponents and then evaluate. So 2 to the negative 1 is 1 over 2 to the power of 1, which is just 1 over 2. This one is going to be 1 over 3 squared, 1 over 9. 1 over 4 to the power of positive 3, which is 4 cubed is 1 over 64. Okay. So the negative exponents in the denominator. Okay, so again, use the rule for division of fractions. Division of fractions is something that confuses a lot of people. Where did I go here? Okay, let me just show you here how to do this fully here. So if I had 1 over 4, let me write this a little bigger here. So 1 divided by 4 to the negative 3. Well, if we're going to make that a positive exponent, we would really have 1 over, and then we have to flip to make this a positive 3. We have to rewrite this as 1 over 4 to the positive 3. Okay, so now I'm dividing 1. I'm dividing 1 by 1 over 4 to the 3, where I can rewrite that as 1, okay, divided by 1 over 4 to the 3. Well, when we divide fractions, again, we got to use we learned this in grade 7, grade 8. We're going to multiply. Let me use my dot for multiply. We're going to multiply that, and we're going to flip that over. So it's going to be 4 to the 3 over 1, or just 4 to the 3. So the answer is just going to be 4 to the 3, and there it is, right there. So that's the long way of doing, of doing 1 over 4 to the negative 3 equals 4 to the 3. The short way is this. Okay, the short way. Well, if 4 to the negative 3 becomes 1 over 4 to the positive 3, then if it starts in the bottom, it's going to end up on the top. So if it started on top, if your negative exponent is on the top, it's going to send whatever your base is to the bottom of the fraction, and vice versa. If your negative exponent let me do this in green here. So if your negative exponent starts off on the bottom already, so 4 to the negative 3, well, that's going to get it, it's going to send that base to the top. So it's going to be 4 to the positive 3. Okay? All right, let's keep doing some more examples. Okay, so here is the, here's the rule. So highlight this in your textbook. This is the rule here, okay, of integral exponents. Again, the key thing is that a cannot be 0, because we cannot divide by 0. That would be 1 over 0, and no good. Okay. All right. Simplify, express with positive exponents, and evaluate without using a calculator. I still follow my rules here. So if I'm multiplying, okay, powers, I'm going to add the exponents. So I have 4 to the 5 plus negative 3. So 4 to the 5 plus negative 3 is 4 to the 2. 16. 3, 2 plus negative 5. You can put it in a bracket there if you want. Okay, so you don't get confused with all these signs. So 2, really, it's 2 minus 5. So it's 3 to the negative 3, or 1 over 3 to the positive 3, which makes it 1 over 27. Okay, 1 over 2 to the negative 5, well, that's just going to send that 2 to the top, so it's going to be 2 to the 5, which is 32. All right, we have 6 to the negative 7 divided by 6 to the negative 5. All right, there's a couple ways you can do this, okay? Let's just stick with what we know, okay? The bases are the same. I'm dividing, so I'm going to subtract my exponent. So I have 6 to the negative 7 minus, use a bracket here, negative 5. Okay, why minus? Because I'm dividing. Negative 7 minus negative 5. That becomes 6, negative 7 plus 5, 6 to the negative 2. Keep going over here. 1 over 6 to the positive 2, 1 over 36. All right, 2 to the 3, that in brackets to the negative 1. Okay, well, everything goes to the bottom, okay, or it gets flipped around. So here we go. We have you know, put that 1 over and then 2 to the 3. Let me just redo this one fully. Okay, so 2. We're going to multiply our exponents. It's going to be 3 times negative 1, which is going to be 3 to the negative 3, and then that's how I got to there. And then 2 to the power of 3 is 1 over 8. Okay. Keep rolling here. Identify the following as true or false. Okay, what do we have? So 8 to the 3 divided by 8 to the 1. So we have 8. 3 minus negative 1 is 3 to the 4. Correct. Okay. Here we have 8 to the 3, 4. Well, we can't do this one because well, actually we could. So we can change that to a this might get a little harder here. Okay, I'm actually gonna, yeah, we can't do this one for now. Let's just say we can't do it because our bases are not the same. Okay, so 8 and 4, you know, we can't just divide 8 and 4. All right, so that one is no good. Okay, so let me come on, get rid of that one. Okay, 8 to the negative 3 is 1 over 8 to the 3. Great. 9. Okay, be careful here for this one. Okay, the exponent is not on the 9. Okay, if there was a bracket here, then by all means the 9 would get sent down below, but the negative 3 is only affecting the a, so it should be 9 over a to the 3. So this one is false. Moving on. Okay, simplify and write the answer with positive exponents. I'm not going to do all of these. I'm just going to do a few of them here. Okay, so if you get the hang of this, okay, by all means move on. Okay, here we go. We're multiplying. Bases are the same, so I'm going to add my exponents. So a to the negative 4 plus negative 3, a to the negative 7, and then key thing is positive exponents, so 1 over a to the 7. 6x squared divided by 2x7. Well, 6 divided by 2 is 3. And then I have x2 minus 7. 3x negative 5. And that becomes 3 over x to the 5. All right, y. We have y. 6 minus negative 5. So again, let me rewrite this one. Okay, I have y on top here, and got 6 minus negative 5, which becomes 6 plus 5. There's a 2 on the bottom here. Don't forget that 2. This becomes y to the 11 over 2. All right, let me do this one quickly here. Okay, so here we go. Negative exponent, this whole thing gets sent to the bottom. So 1 over negative, put a bracket here, negative 2x to the positive 3. That becomes 1 over negative 8 x to the 3. 8 and 4 become a 2. A to the negative 5 minus negative 3. Oh, whoa, 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 Mr. Vidich, slow down here. Okay, that's a B, that's an A. We can't do those. Okay, so we're just going to leave them as, we're going to just change the exponents to positive exponents. Okay. All right, so let me just erase this. Okay, so A to the negative 5, B to the negative 3. Well, they're just going to flip-flop around. The B is going to come up, and the A is going to go down below. All right, here we go. We have 5P to the negative 2 over 5Q to the 4. So let's just make a fraction here, and the 5Q to the 4 is on the bottom, and it's going to get joined by 5P squared. And then when I, there's got to be a 1 here. Once I take everything away from there, now I have 1 over 5Q to the 4 times 25P squared, or 1 over 125 Q to the 4 P squared. Okay, I'm trying to get through these. Okay, how many more do we have? Okay, a couple more here. All right, pretty long example here. Okay, stay with me on this one. I'll try to get through it. Here we go. So try and simplify as much as you can. Let me just ignore this little first part for a bit and just work with the fraction. So I have x's and x's. So let me deal with those. So first of all, I'm going to rewrite this 15 and then x to the 3. Okay? Y to the 6. And then I'm going to have, how many z's do I have? I have negative 1 on top and 2 on the bottom. So I'm going to end up with z to the 3 on the bottom. And if you can't see that z to the 3, let me do it off to the side here. Z to the negative 1 divided by z to the 2 is really z to the negative 1 minus 2, which is z to the negative 3, which is 1 over z to the positive 3. And that's why the z's on the bottom. Okay? Now, let me rewrite this one. And I have 5 x to the x cubed, y to the negative 8, z to the negative 2, and I'm going to multiply this, and I'm going to flip around this fraction because I'm multiplying, so it's going to be z to the 3 on top, 15 x to the 3, y to the 6 on the bottom. All right. First, I'm going to do my coefficients. So I have 15. So let me write a big fraction here. 15 on the top, 5 on top and 15 on the bottom. That simplifies to 1 over 3. Okay, that becomes a 1, that becomes a 3. Now I have, let me do my x's first. Okay, so x's, I have x to the 3, and then minus 3 on top, on the bottom I mean here. So I'm dividing 3 minus 3. That looks like it's going to get rid of my x's. I have y to the negative 8 minus 6. And it looks like I have z to the negative 2 plus 3. Okay, why plus in this case? Well, the z's are on the top. Okay, I'm multiplying whatever's on the top and dividing whatever's on the bottom. Okay, let me simplify this. So y to the negative 14, z to the 1 over 3. Finally, it's going to be z on top over 3y to the 14. Okay, let me do one more here. Explain why 2p to the negative 3 does not equal 1 over 2p. Simple reason is because the 2 is not affected by the negative 3. In other words, the exponent on the 2 is 1. This, however, 2p to the negative 3 would be 1 over 2p to the 3. So here is a quick shortcut now. If you have a fraction, and a fraction that's getting raised to an integral exponent. So here we go. So really, we have 1 over 2 to the 3 to the power of 4 here. And then we have 1 over 1 divided by 2. So 1 over 2 to the 4 over 3 to the 4. And then because I'm dividing, I can flip that around and multiply it. So it's really 3 to the 4 over 2 to the 4. So my answer is going to be 3 to the 4, 2 to the 4. So let's look to do a full circle here and see what happens. So we started off with here, and we ended up over here. So let's look at what happened, okay? Okay, well, I had 2 over 3. Now I have 3 over 2. And they both have the exponent 4. So what does the negative exponent do? It flips your fraction around, okay? So let me see if that rules. Yeah, the rule's in the bottom here, so we'll get there in a second. So 3 to the, this is fairly easy, 3 to the 4 over 2 to the 4. Okay, and that simplifies to, I believe, 81 over 16. So classify the following statement as true or false. Does, well, let me get an answer for here. That becomes 81 over 16, okay? Well, definitely true, okay? If that 2 to the, if they're both 81 over 6, then it's true. They're both equal. And then suggest a quick method for evaluating 5 over 2 to the power of negative 3. The quick method is, I already mentioned it, flipping around the fraction. So if you have a negative exponent and the fraction is the base, you take the reciprocal of the fraction and you make your exponent positive. Okay? Done. See you guys in class. Hope you enjoyed that video. I'll try to make it short and sweet. Again, if you're getting this, and you're watching the video, if you just hit the right arrow button on your calculator, it'll make me go fast forward 4 seconds at a time. Or if you miss something and you want to go back up 4 seconds, you can hit the back arrow. All right. Hope you enjoyed it. See you in class. Bye.